etmiştim ama e, translate'i siz yaparsınız. Şöyle yapayım. Öncelikle biz Ferhat hocamıza hoş geldin diyoruz. Hem üniversite adına hem de fakülte ve bölümümüz adına, hocalarımız adına katkılarından dolayı şimdiden çok teşekkür ederiz. Gerçekten bizim bu davetimizi kabul ettiği için bizi çok memnun etti. İnşallah bir gün burada da ağırlamak isteriz. Burada yüz yüze görüşmek nasip olur. Belki bu bir başlangıç olur. Bundan sonraki ilişkilerde daha şey olur. Yani biz gideriz onlar gelir. Bu bir başlangıç olsun diliyorum. Katkılarından dolayı şimdiden hem üniversite hem fakülte hem de hocalarım adına teşekkür ediyorum. Buyurun hocam. Siz çevirirsiniz artık hocam.
Yeah, Farhad, Professor Solmaz is welcoming you, and he thanks for your. Farhad, do you hear me?
Yes.
Okay, and he welcomes you, and he is thank you for your time to sparing your time for us, and he believes that your contribution is very important for us and for our university, and he's wishing to continue this cooperations in the future, and he's very full of hope for the future works.
Yeah. Thank you very much. It's my honor and pleasure to have this opportunity to be with you, okay, during the next 1 hour. And yeah, I'm here actually to somehow to have a kind of contribution on the AI community.
Okay, let me share my screen and let's start it. Farhad, if you are ready, everybody is ready. If everybody is ready.
Yes, it's okay for me.
Yeah. Okay. I have to quick and come back. 1 minute.
Hocam ses gelmiyor. Mikrofon kapalı herhalde.
Hocam görünüyor değil mi? Şu an sıkıntı yok.
Bir problem yok hocam. Görünüyor şu anda.
Tamam. Welcome everybody. This session is recorded and please aware for this. Today we will talk about we have a guest for our university. He's working in a ML scientist in one of the big companies in Europe, hostelworld.com. He will try to explain us the ongoing works in AI, what is in popular works in AI, so the industry relationships, and so much more about AI industry today. I would like to welcome you all with the name of Professor Bakan, our rector, and the vice rectors, Professor Fettaoğlu and Professor Erşahan. This session will be 1 hour. We will start by introducing our university, just basic information our university. Then I will handle to Dr. Farhad for his presentation. Then we will have some questions and answers. Because of the majority of the people are in Turkish, and we will accept any Turkish questions in the end. We will try to answer them by Turkish, okay? And also the questions and the answers can be emailed to the Farhad, I guess. He needs to allow that. You can reach him if you have any special question about his presentation. Our university is born in 2018. It's called Istiklal University. We are very new university in Turkey, but we are very we're doing very well so far since 2018. We in our engineering department we have 10 engineering departments, and with a total of 19 academicians, and we are very we still receiving new students for this department. We are also in the Faculty of Engineering. We are also open for the industrial developments especially in Turkey, and we focus on especially for the space and defense industry. So we do research and work every angle of these industries. We have very strong industrial relationship with our university. We are not just a university. We are a university with cooperating with the industries. So we are also cooperating with the Turkish aerospace industries, and incoming projects, incoming opportunities. We always welcoming any industrial relationship with our university. We have also several research centers in our Faculty of Engineering, and especially most of the research are going around AI and machine learning, and in any related with these two topics. So I will handle to Farhad. He has, I think, he has a time to do his presentation. Then after that, I will receive some questions for his presentation. The floor is on you, Farhad.
Yeah, thank you. Just let me share my desktop. Can you see my desktop in maximize mode?
Yes.
Okay. Perfect. I don't know if I can have a short, say, explanation about myself or not.
Yes, please. I just missed it. I'm sorry. I had a
no problem. No problem.
I just missed it.
No, don't worry. Don't worry. Yes. It's okay. Hello, everyone. It's say a real pleasure to be here with you today. I'm very happy that I have this opportunity to talk with you. And my name is Farhad REZAZADEH, and I specialize in applied artificial intelligence, particularly in areas where machines are not just, say, analyzing the world, but say starting to create things themselves. I currently work as a machine learning scientist at Hostel World Group, where I focus on data-driven growth and intelligent product development. Prior to this, I was, visiting associate professor at Technical University of Catalonia in Barcelona and a senior applied AI or researcher at CTTC, a key telecom research institute in Barcelona. Over the past few years, I've had the chance to contribute to more than 8 European and national R&D projects, 2 of which resulted in patents and recognition by European Commission from the European Commission. I've also had international research experience in Germany, Spain, and Portugal, and I've published over 32 research articles and 3 books in the AI space. I've won 9 different fellowship and grants from European Commission, IEEE, and government. Today, I'll guide you through a fascinating topic: generative AI. This is the part of artificial intelligence that's say turning heads not just in research lab, but also in industries like art, medicine, education, and even law. We'll explore how AI has evolved. Specifically, when we say AI, I refer to generative AI. From simply recognizing patterns like a detective to creating, say, brand new content like an artist. We'll also look at where this is heading next and why you don't need to be a technical expert to understand its impact or even start using it. Before I begin my presentation, I'd like to share an exciting opportunity. If you're working on AI or generative AI and are interested in publishing in a high prestige venue, we're organizing the 2nd edition of our workshop on responsible and trustworthy AI large language models for 6G networks, also known as a 6G brain, at IEEE PIMRC 2025. It will take place this September in Istanbul. We'd be delegated to see your contribution there and to say connect with fellow researchers committed to advancing trustworthy AI in communication networks. It's a great chance to engage with the community and also explore collaboration. Let's just do a journey together, okay? Let's use our own generative model. You see, because we are building all of these generative networks, and we also have a generative model and a network in our heads, okay? You know, when you visualize something, when you imagine, when you dream, that is your generative model. They're producing some beautiful outputs. How the brain's generative model works. Our brain constantly builds a mental model of the world, okay? Not just to understand the present, but to simulate what might happen next. This inner model is called say generative model because it can generate possibilities, fill in missing information, and create predictions. Okay, please close your eyes and imagine you are on a beautiful beach during sunset. Okay, now open your eyes. Imagination, creating actually without input. When you imagine a beach, your brain doesn't need to see it, okay? It reconstructs the idea of a beach from memory and experience. Sunlight, sands, wave, almost as vividly as seeing it. This means your brain is generating internal representation without real-time sensory input. This is the same mechanism artists, scientists, and dreamers use to invent and innovate, okay? Prediction, simulating the future. Every moment, your brain tries to guess what will happen next, okay? What will someone say? What will happen if I cross the street? What comes after this sentence? You know, it uses past experiences, current context, and learn patterns to simulate future outcomes. This prediction helps you to react quickly, avoid danger, make decisions, and learn efficiently, okay? And we have a feedback loop that is exactly predict to compare and then to update. When say your brain predicts, is compare the expected result with the actual outcome or result. If there's say a mismatch, it updates its model, okay? This loop, predict, test, adjust, is how learning and adoption happen. It's the foundation of creativity, planning, memory, and understanding the world, mirroring the same principles we use in building artificial generative models like GPT. But what is the difference between discriminative models like traditional deep learning and generative models like, say, ChatGPT? Imagine two characters, Sherlock Holmes and Picasso. Sherlock stares at a crowded crime scene. Footprints, a cigar ash, turn paper and boils it down to one conclusion. The butler did it. That's classic discriminative, AI. It narrows vast data to the most likely label, spam or not, dog or cat, approved or declined. Picasso starts with a tiny dump of paint and explodes outward into a full mural, into a field, say, mural. And generative AI behaves like that. It takes a tiny seed, okay, maybe random digital noise or a short text, say, prompt, and grows it into a high resolution image, a brand new melody, or even a 3-paragraph story. It doesn't just pick from old examples, okay? It imagines inside, say, inside a mathematical sandbox, okay, called a latent space. You'll hear that term again, but for now, think internal, say, sketchpad. How does generative model actually work? Under the hood, the model has, say, crunched millions of examples, images of faces, paragraphs of Shakespeare, hours of jazz, and, say, distilled their essence into a cloudy, high-dimensional cloudy and high-dimensional map. When you drop in a seat, it's like placing a pin on that map, okay? The algorithm then walk outward, painting or wording in details that make sense according to everything it has learned. You might ask, isn't that copying? Great question. Legally and technically, it's statistically creating something fresh. It doesn't paste any single training image pixel for pixel, but it can echo overall styles, which is why ethics and copyright debates are heating up. Every couple of years, the research community cracks a fresh nut that widens, say, the art of the possible. GANs, where two neural nets in a playful duel, one creates, the other critiques. Results, selfie of people who don't exist. Picture to say toddlers with building blocks. One stack blocks into a house, the other say knock it down if looks fake. Over thousands of rounds, the builder gets really good. That's a GAN. Why care? Because this technique shattered a psychological barrier. People saw a portrait that felt, we say, utterly real, yet was algorithm burned. And suddenly AI creativity wasn't, say, sci-fi anymore. The flip side was the fakes of politicians promoting society to think about authenticity in a photo-obsessed, say, world. Transformers added an attention trick, so the AI remembers the whole sentence while writing the next word. Okay, just like we glance back in a text thread. Imagine reading an entire paragraph before answering a question instead of just last sentence. That meta reading skill is what attention feels like to an AI. When scale up, say, picture a virtual library of Wikipedia plus public, say, books plus Reddit. The model becomes a surprisingly fluent pen pal. This is why tools like ChatGPT can outline a birthday speech, suggest bug fixes in JavaScript, or role play a language tutor on a Sunday night when humans are asleep. Then came large language models, LLMs, such as GPT-3. They got RLHF, that means reinforcement learning from human feedback, which is geek speak for people nudge them to sound polite and helpful. In 2023 and 2024, we began to see the emergence of AI agents, language models that don't just respond, but can actually take action. These agents can use tools like search engine, calculators, APIs, or even control your email or calendar. They have goals, short-term memory, and can say chain tasks together to help you solve complex problems. This was made possible by combining powerful LLMs like GPT-4 with, we say, a framework for decision-making such as AutoGPT, LangChain, or OpenAI function. LangChain somehow is the most famous, say, framework in LLM and generative AI community. These are the first step toward digital assistants that works like junior employees, okay? Fetching, filtering, and even executing tasks on your behalf. Finally, multimodal. Multimodal means you can show the system a doodle, whisper an idea, and it replies with an illustrated, say, a storybook page, all in one go. Think of, say, bilingual friend who can flip between Portuguese and English, or Turkish and English without translating word by word. Okay, they think in concepts. A multi-modal model is, we say, bilingual in pictures and prose. It learns that, say, the text sunset over the ocean, and we say pitch orange photo of a beach belong together. Once that mapping exists, the narrow goes both ways: captions to image or image to caption. Layer on audio, and you have the, we say, seeds of automatic documentary making, say script, visuals, narration, soundtrack, all as one pipeline. So let's break it down and explore some, say, real world examples of how generative AI is already transforming different, say, sectors, not in the future, but right now. These aren't just lab experiments, they're tools people are, say, using today. Let's start with art and design. Let's say you're a designer, okay, and your client write, say, a new logo, and in the past you would sketch a few, say, ideas, maybe refine 2 or 3 concepts over hours. Now with generative AI, you can describe what you want, okay, modern, minimalist, blue and white with a mountain, and get 50 variations in 5 minutes. It's like having a, say, visual design assistant. It doesn't replace the designer, but it gives them a way more to work with and much faster. Entertainment. In games and storytelling, AI is, say, making characters more alive. For example, imagine you're playing a video game and you meet a character in the forest. Instead of repeating the same pre-written lines over and over, this character remembers your actions, responds with fresh dialogue, and even develops a relationship with your character over time. Generative AI lets developers create adaptive, dynamic stories, making gameplay more immersive. Marketing. Marketing, say, used to be one size fits all, okay? You would get the same ad as everyone else. Now, if you have browsed red sneakers or eco-friendly travel backpacks, a generative model can create a custom ad image or slogan just for you, reflecting your style and preferences. It's fast, cheap, and effective. And companies love it, okay? Because it boosts engagement. Healthcare. One of the interesting area related to generative AI is healthcare. Here is powerful one: drug discovery. Normally, designing a new, say, molecule to fight a virus or disease takes years. Generative AI can, say, simulate millions of molecular shapes in days and suggest which one might work. It's like having a super fast scientist brainstorm chemical ideas 24/7. This doesn't mean, say, AI replaces medical researchers, but it gives them smarter starting points for real world testing. The next one is education. Imagine you're a student learning about ancient Egypt. Instead of just reading a paragraph in a textbook, you could chat with a virtual tour guide who takes you on an interactive field trip through a 3D version of the pyramids, okay? Or the AI could rewrite their lesson at your reading level or quiz you in a fun way, okay? Generative AI helps make learning more personal and engaging, especially for students with different learning styles. Manufacturing. In product design, engineers can use generative, say, AI to automatically generate 3D parts based on performance goals. Let's say you want a drone arm that's, say, light but strong. You give the AI your constraints, and it generates a shape that no human might have thought of, and it works. Even better, that part can be tested in simulation before it's ever built. Financial and legal. Legal contracts and financial reports are often over, for example, 100 pages long. Generative AI tools can read and summarize them in seconds, given a one-page summary with the key points. It doesn't mean you fire your lawyer, okay? But maybe now your lawyer doesn't have to read, I don't know, 10,000 pages to find the three important, say, ones. When, say, let me back a bit and discuss about machine learning, okay? When we write traditional, say, software, we hand code every rule. If condition A, then do B. Machine learning flips that around, okay? We feed computer lots of examples, pictures, spreadsheets, game logs, and it figure out its own rules. Think of it like, say, training a chef by letting them taste thousands of recipes until they know how to replicate and invent, say, flavors. The more data we provide, the better sense the system develops. Now, probably you are aware, okay, about the different approaches that we have in machine learning, but just let me say quickly explain them. We have supervised learning, unsupervised learning, and reinforcement learning, okay? This is the three main machine learning approaches in this area. But supervised learning is like teaching a child with, say, flashcards, okay? You show dog face equal to, say, dog, and show cat face equal to cat. And then they can label new photos correctly. We have, say, unsupervised learning is more like, say, giving a child a box of mixed Lego bricks and letting them, say, sort by shape or color. No labels, just pattern discovery, okay? And we have reinforcement learning, mirrors training a puppy with treats. The system tries, say, actions, get points for success, like winning, say, a chess match. And over time, it learns the winning moves, okay? Now let's actually explain artificial neural networks with a very maybe interesting example. And during, say, explaining these examples, somehow I try to explain different concepts and techniques that we have in say, artificial neural network. Think of a neural network like a cookie factory, okay? We have first input station or ingredients in, okay? You dump in bowls of, say, flour, sugar, eggs, and chocolate chips. the raw data, okay? In machine learning terms, this is your input layer receiving feature values, okay? The next is mixing department, first hidden layer, okay? Workers or neurons combine ingredient in set proportions that we called it weights in machine learning. Each worker measures, for example, 2 cup flour, multiple 0.5, or 3 eggs, a multiple 0.8, then say sums everything up, okay? And then we have ON department, that is play roles like activation function in machine learning. The mixed butter goes into oven, okay? That only let dough that's above a certain temperature, or that means threshold, actually bake, okay? In neural networks, that's like a ReLU or sigmoid function, deciding which signal pass through, no? And we have a decorating department, okay? In this factory, we have a department, it's called decorating department, or subsequent hidden layers, okay? Now the cookies come out plain. Other teams add sprinkles, shape them into hearts or stars, or pipe on, say, frosting, more layers of transformation. Each layer learns ever more refined patterns, from baked cookie to, say, chocolate chip cookie, to, for example, cookie with blue icing. Next, we have quality control and packaging, or output layer. The final inspectors sort cookies into, say, boxes labeled classic, sugar, or double chip. That's your network's prediction, okay? It's classify or generate a final result. And we have recipe tuning or training, okay? After tasting, you might tell the first mixer, okay, use 10% more sugar, and tell the decorator, add fewer sprinkles, okay? These feedbacks travel back through the line that we called it back propagation in machine learning, adjusting each station recipe, say that we called it weight, and so future batches match the target flavor minimum or somehow minimize loss, you know. And we have avoiding over decorating or regularization. If you let the decorator go wild, every cookie ends up, or say, loaded with say sprinkles and taste inconsistent, and like the concepts of overfitting that we have in machine learning. By occasionally skipping the decorator exactly play role of say dropout techniques in machine learning, or limiting how much say frosting they can use weight penalty, for example, and you keep the factory flexible, and the cookies, we say, reliably say tasty on any new order. Now, imagine you could teach a machine not just to recognize pictures or translate your emails, but to actually invent new ones, paint, say, portraits, draft stories, compose music. That's the magic of generative AI. Under the hood, this system learn the system learns a kind of a map, okay? A probability map of what makes sense in a domain. Today, I'll introduce you into 5 flavors of these creative engines, each with its own recipe, okay? Strengths and trades-off. Each of these 5 families, that means GANs, autoregressive, VAEs, diffusion, and flows, offers a different trade-off between realism, interactivity, speed, and mathematical rigor. Choosing the right one depends on, say, on whether you need photorealistic textures, uh, fluid conversation, say editable sketches, or large creativity for text prompts, or say rock solid probability guarantees. Let's start with GANs. Generative Adversarial Network, or GANs, work, say, like a friendly, say, rarely, okay, between 2 artists. One, the generator, tries to sculpt images that look real, while the other, the discriminator, plays critic, flagging anything that seems off, okay, as they spur both sharpen their skills. The generator gets better at, say, fooling the critic, and the critic gets, say, keener at spotting fakes, okay? The results. Stunningly realistic images and textures, okay? The catch is that these competitions can be hard to manage, okay? Training can feel like trying to tame a wild, say, stallion with carefully balanced rules and frequent say collaboration say needed. That means is in terms of resources is heavy and complex. We have actually autoregressive models, write or say speak one token at a time, and always picking at everything that say came before. Picture novelist who writes one word, then read, say back the whole sentence to decide the next word, okay, and repeats. By stringing together 1,000 of these, what comes next, decisions, the model can draft, for example, essays, carry on a chat, or even translate languages. They shine in delivering coherent context-aware text, but they hunger for massive text libraries and considerable computing power to keep track of long conversation. Variational autoencoders take a 2-step approach. First, they squeeze data into a compact, abstract sketch. Then they, say, inflate that sketch back into a full-fledged image or sample. Think of an artist who, say, makes a charcoal drawing of a photo. That's the encoder, and then uses color and details to bring it back to the life, the decoder. This compressed space is smooth. You can slide around it to tweak features like style or color, and making a VA is ideal for interactive editing and say filling in missing pieces. However, the final creations tend to be a bit softer around the edges. compared to the crisp realism that we have in GAN's methods.
Farhad, we are a little bit getting short of the time. Okay.
Okay. Just I try to be more quick. We have also diffusion models, flip the usual process on its head by starting with noise and gradually, say, chiseling it away. During training, they learn, say, tiny steps of how to add noise to an image at generation time. They run those steps in reverse, turning, say, a random static into a clear picture. This, say, slow, careful refinement yields a beautifully detailed and diverse result, which, say, explains why many cutting-edge text-to-image tools such tools use diffusion under the hood. The downside is that each, say, step takes time, though recent innovation are speeding up the journey from noise to masterpiece. And we have the flows promise perfect reversibility. They learn a series of exact invertible twists that map complex data into a simple shape, like a squishing a cramped piece of paper into a simple shape, sorry, into a, say, a neat rectangle, and then unfolding it back, say, without actually tearing. Okay, this exactness means you know precisely how likely any given sample is, making flows invaluable where mathematical certainty is crucial. Think scientific simulations, a high fidelity voice, we say, synthesis, but the precision comes at a cost. And these reversible transformations can be heavy on memory and compute. They say they are trickier to scale. Just very quickly to show a very, say, simple and interesting example of generative AI in action, I've chosen a short story, okay? If I pronounce correctly, Cloglan, okay? And the Whispering Forest. I provide the storyline and scenario you see on this slide, and to an, say, as an input to an AI platform or generative AI model, which then generated visual, sound, and ultimately create a video based on this story. Before we play the result, please take a moment, just about maybe less than 1 minute, to quickly read through the scenario shown on the slide. Okay, let's play. Do you hear the voice of the video?
I mean, can you play?
Now I play. Just let me if you hear the voice.
No.
No. Okay, no problem, because it has music, and I don't know how I can play it with voice, but just let me to play it and show it. Okay, this is generative by generative AI models, and based on the text scenario that I provided in previous slide. Yeah, unfortunately, you cannot hear the music in the background, and also a lady that summarized the story. Okay, just I wanted to show you a very simple examples that you can see every elements, every figures is generated by AI here in this. Actually, is a short video or animation about the scenario or a story that I put it in previous slide. And this is just a very simple example how is the power of generative AI, and it can exactly generate for us what we imagine, okay, what we expected, okay, and every time they provide us unique output and results. I don't have time to speak more or explain more about this, but let me just highlight the key features here. We have the text to video generation, we have a storyboard creation, we have character consistency, okay, we have camera and scene control, and we have audio integration. Yeah, again, thank you very much for inviting me to this session. I just try to simply introduce the generative approach, but please consider it is like an ocean. It is like an ocean. It has full of, you say, techniques, method, mathematics, and here I have just tried to simplify the explanations and just give you an introduction how much it can be, for example, interesting to follow or work on this research area for a specific domain. Okay, it is not just for example, image processing. It also has a lot of applications in different industries, as I mentioned in one of the slides. Yeah, and thank you for your attention and consideration.
Thank you. Thank you, Dr. REZAZADEH. We appreciate your presentation. I think there are lots of needs to be understand for the generative AI, and I think there are lots of research topics will be generated from this area.
Yes, sure.
I have a very quick question because
Yes.
I interested with some models.
Yeah.
Like for example, if we think about this generative models,
Yeah.
how much it will be grow in the there's any limit, or there will be any burnout of the algorithm, or what will be the end?
About the future, you mean, or about the current,
Yeah,
approaches?
I mean, we go there. I think we
Yeah.
just because you just play with us very like brain,
Yeah.
blowing the story, because you just,
Yeah.
I think you just give like a half a page story, and
Yeah.
it just make the story of it,
Yeah.
like
Yeah. Exactly.
pages of the story of it,
Yeah.
and you put the music on the top of it, right?
Yeah.
Yeah.
Now we have two main, research direction here. Okay.
Mhm.
One of the important one is about to somehow try to find solution to process these procedures, okay, internal procedures with less computing resources, okay, because everything here is about computing resources. You need
Yeah.
very high powerful GPUs, for example,
Mhm.
to render, to compile, to process different steps and building blocks in these methods. So
Right.
one direction is exactly is this, that to try to somehow contribute on current famous solutions and integrated innovative approaches to them, to somehow reduce the complexity of this approaches, okay,
Right.
while provide same or even better performance. You know, this is one approach. Another approach, there is another point here is exactly no any say limitation. You can suppose you can integrate different models, okay? You can integrate different AI machine learning methods to these algorithms or to these methods, and you can create something very, very novel. So there is no say stop point, okay? You can imagine, for example, one of the works that now I'm working on that is about the foundation model, okay? That means how, for example, train a model that be able to apply this trained model in different domains, that these domains are completely different together. Because if you want to, for example, apply in, I don't know, in a specific domain, you need to train AI model on for based on that specific environment. But now we have, for example, foundation models that enable us train our AI model with very, very huge data, okay? And then fine tune it for say downstream task or specific task. So there are a lot of say concepts. There are a lot of technology. There are a lot of, and you know, today we have this, and maybe next month we have another things. And yeah,
I
the
mean,
pace, yeah.
Last year in this time, people maybe doesn't know. You and me were colleague
Yeah.
in CTTC.
Yeah.
So
Yeah.
we were talking about like beginning of the LLMs. Now it's just something different,
Yeah.
and it just very big milestone for the AI community.
Yeah.
Also, there are many, I think, aspects and the factors, especially like in sustainability, in energy consumption of the machines, and algorithm efficiency.
Exactly.
I think we are not really finished this
No.
this research. I think
No, never.
yeah,
Yeah,
there are
never.
many things to do. Okay, so there are some questions. Let's cover them very quickly because we are over 1 hour.
Yeah.
Okay, Professor Koshan asked about what do you think about the fact that generative artificial intelligence products are not well understood at some points and are overrated at others?
I
I
don't
think
know what he means exactly. Okay,
I think he's trying to ask the comparison of the other, like if we consider one product generative AI, what is the others differences?
Each
Like
one is specialized.
discriminative AI, for example.
Okay. As I explained, if talking about the other AI models, like deep learning, like I don't know, reservoir computing, like other different algorithms that be classified as discriminative AI methods, and the generative AI, as I explained, everything is about on that method. We have say a kind of detection, okay, but in generative model we have a kind of creation, you know. I explained that this is like detector, and the generative AI is exactly like an artist, you know.
Yeah. Second question is from Professor Solmaz.
Sorry if I get the point, the question is okay. Yeah.
Professor, yeah, I think he's okay. He's happy. In artificial intelligence, in the short term, in the mid-term, what do you think about in the software industry and engineering for the in the short term, in the mid-term, how it will be affect for the industry and the students? What we need to care about for our students when we are teaching them
Yeah.
like?
Yeah. Thank you. It's very, very nice question, like previous question. Just give me time, okay? I don't know. I know that our time is finished. Just let me just a bit explain. I refer to transformer, okay? Transformer is an architecture in generative AI and large language model that somehow revolutionized this say research area. The first time it is introduced by Google, okay? But never they they didn't say understand how much this technology can be important. And after that, it was OpenAI that used this architecture and method, and then we say introduce OpenAI. So sometimes we, for example, introduce some methods. At that time, we don't understand, even ourselves, I mean, we don't understand how much it is important. After some years, we understood this. But take into account, now we have a new concepts after generative AI, okay? It's called uh, artificial general intelligence. Okay, this is a step after generative AI. The point in artificial general intelligence is we have an AI agent that be able to solve and reasoning and solve and make decision on the problem that is not trained over that. Okay, that means be able to solve unseen tasks. You know, so still we are working on generative AI. Now the research community introduce artificial general intelligence, you know? So it's important somehow about the student that I ask is, I think it's important to try to encourage your students, okay? At least do some hands-on, okay? On generative AI, say concepts. Nowadays, we have a frameworks like Llama Index, like LangChain, that helps, for example, the students to design a specific generative AI algorithm or LLM algorithm without need to go deep into the code. You know, you use some libraries that these libraries maybe consist of 1,000 lines of code, okay? And it helps you to, for example, done a simple project, for example, design a chat box in some hours, you know? So maybe using this kind of tools and frameworks is very, very good start point for students, and also encourage them to do some project related to the specific course that we have. That means not necessarily that course should be software engineering, programming, or for example, artificial intelligence or machine learning. Maybe it's about other, courses with other topics, but of course, generative AI, large language model can play roles in every domain.
Right. The second question is okay. The artificial intelligence, if we imagine it's like a phenomenon, you know,
Mm-hmm.
like it replicates some human brain activities.
Yeah.
What do you think about this?
The point is, okay, the questions are very nice. Okay, some of them is philosophical question. Everything that we have, because as I explained, the artificial neural network is based on biological neural networks. Okay, so every solutions, every approaches, every algorithms that we have in AI, in generative AI, in large language models, somehow they are inspired from the brain functions, okay, about learning. For example, if we have reinforcement learning, this is exactly a kind of learning that we have. Suppose we have a child, okay? This child learn many things based on trial and error and interact with the environment. Nobody, no, for example, nobody teach a baby to walk, okay? But at the end, she or he learns to walk. This is a kind of reinforcement learning that we have in our brain. And based on this kind of approaches, we inspired, and now we have a reinforcement learning approach that is very, very powerful machine learning method. Okay, so I can say somehow everything that we at this time we have about AI, it inspired from our nature, from our world, and specifically the human brains.
Yeah, okay. I think we don't have other questions. Muhammed Hocam, YouTube'dan bir soru var mı? Yoksa kapatalım mı hocam?
Yoktur hocam.
Tamam. Okay. We are ending this session. If there is any questions, I think Dr.
Sure.
REZAZADEH we will happy to answer with your
Sure.
emails. His emails are here. And I really, really appreciate your time and your efforts for this. I think it was a very effective session for us. And we, as a university and as a department, we want to grow our networks, and we want to know what the community does in recent at the moment, instead of like studying LLMs today, right?
Yeah.
Because
yeah.
yes, so it was very effective session for us.
Thank you.
We really appreciate your help.
Yeah. Just again, let me say thanks to you, Dr. Ertigal, to invited me. Thanks to your department, professors, students, and your university that gave me this opportunity to say somehow meet you and talk with you. Yeah. Thank you.
Hocam sertifika için Ramazan hocam.
Merhaba hocam. Reza hocamız eğer ekranını bir şey yapabilirse onu siz yansıtabilirsiniz. Siz
Farhad, can you close your screen because we
Yeah,
have
yeah,
a session
yeah.
for your certification.
Yeah, thank you.
Okay. 1 minute.
size ek şey yapmıştım değil mi hocam?
Okay. Hocam nasıl yapalım sertifikayı?
Yaptınız mı hocam? Sizde şeyde var mı slaytınızda?
Hocam ben kendi ekranımı paylaştım. Görünüyor
Tamam.
mu hocam? Hı hı.
Ben şimdi küçülttüm de hocam bir saniye.
Ertuğrul hocam sizin ekran görünüyor. Sertifikada görünüyor. Ramazan hocam isterseniz oradan şey
Tamam hocam.
yaparız.
Ben şey yapmıştım görünüyor. Hocam çok teşekkür ederiz katılımlarından dolayı. Gerçekten güzel ve verimli oldu. Belki arkadaşlarımızın bu konuda ufuklarda yani görüşleri de açılmıştır veya işte bu konuda yeni düşünceler gelişmiştir. Bize zaman ayırdığı için çok teşekkür ederiz. İnşallah ileride daha güzel ortamlarda görüşmek üzere diyelim. Hocamızın da çok vaktini almayalım. Teşekkürler.
We like to thank you as a department and as a university, in name of Professor Bakan, our rector. And we appreciate your time and your efforts for this session. And we are open for the new collaborations in the future.
Sure, sure. Thank you again for the
Thank you.
opportunity. Thank you.
Thank you, everyone. Thank you.
Bye.
Thank you very much.